If you require any cryptocurrency development, be it with tokens, NFTs, Bitcoin forks, or really anything within the cryptocurrency space, make sure you check out my Buy Me a Coffee page where I offer all kinds of different consulting to help you figure out how to deploy your cryptocurrency solution. But without further ado, let's get on with the video. How's it going, everybody? Devoski here, the last hodler, and this is going to be a video about how to deploy an ERC20 token to the Ethereum mainnet. So let's just jump right into it. I have a few dependencies here that will all be in the description how to install them, but you're going to need all of this stuff to kind of set up your environment so that you can be where I am right now. The first thing we have is VSCode. That's the IDE that I'm using to write all the code and do the deployment. And I'm also using a terminal called Windows Subsystem for Linux. So they're going to be in the description on how you can get those. Make sure you install those and then you'll be ready to follow along with me. So once you've opened your VS Code and you have your VS Code open, something like this, the next thing you'll need to do is you need to click Terminal and then New Terminal, and then you'll get a brand new terminal here. Make sure it's Windows Subsystem for Linux. If you don't have it set up for Windows Subsystem for Linux, just check out the description where I'll have a little guide on how to set that up. But once you've set that up, you'll be ready to start typing in some of the dependencies that we have here to deploy our ERC20 token on the Ethereum mainnet. So we're going to be using something called Truffle, which is basically a piece of software that allows us to seamlessly develop and deploy contracts to Ethereum or any layer 2 like Polygon, Avalanche, whatever you like. That's Truffle. So that's the first thing we're going to be installing, and we're going to be installing it via Node Package Manager, that's NPM. So make sure you type this command into the terminal as the first thing that you do. Once that's installed, we're going to actually start a new Truffle project by typing truffle init. And then you'll get something like this kind of folder structure here. You'll see something like that. And the next thing to do will be to go into the configuration file of that folder. Well, that's truffleconfig.js. And we're going to add a little bit of configuration here so that we can get started with our project. There's a couple of dependencies here as well that we're just going to include, and I'll explain a little bit later what they do. So just type in these two commands, and then as we go along this tutorial, I'll explain exactly what we're talking about here. So the first one is npm install OpenZeppelin contracts, and basically, roughly speaking, we're going to be deploying our ERC20 token using OpenZeppelin's like standard library of contracts. We're not going to be writing anything from scratch here. We're just going to be deploying some already tried and tested contracts that everyone's using out there in the space right now. So there's no need for us to write anything from scratch. And it's just safer to use pre-established, already existing contracts. So that's that one. And the next thing we're going to install is something called hdwallet-provider, which allows us to hook up our MetaMask wallet, or really any wallet with a seed phrase, into our Truffle project so that we can deploy our smart contracts and pay the gas fee that's going to be required. It's going to cost, right now with the Gwei price being about 60 Gwei, that's the gas price of Ethereum, it's going to cost about $300 for you to deploy your smart contract. So it's not cheap, and we're going to need to hook up our wallet to our project so that we can actually pay for that. So you're going to need a little bit of Ethereum in your wallet. The wallet that I would recommend using for this is a wallet called MetaMask. Link is in the description. And it's basically a browser-based wallet that you can store Ethereum tokens on, or just normal Ethereum. And within that wallet, if you just open it up and you go into your settings and you go into security, you can reveal your seed phrase, and you'll have a seed phrase that you can now hook up into this Truffle config file, which will enable you to use your wallet within Truffle. So this mnemonic here, this mnemonic word, this would actually represent whatever your mnemonic is. And it would just be a bunch of words like, let's say, chocolate, bottle, bird, calendar. It's just going to be a bunch of words like that. I think it's like 16 words, and that represents your private key, or at least, a collection of words from which your private key is generated. So make sure you find that and put that in quotations where the word mnemonic appears right here. But I've just got the word mnemonic here just to represent that we need that to happen. I'm not going to put my mnemonic here because I don't want to compromise my wallet. So I'll just go through this file and explain pretty much everything that you need to know. I'll have this text here in the description of the video so that you can simply just copy and paste what we've got here. But just for educational purposes, I will explain exactly how everything works. So now that you've typed in npm install truffle hdwallet-provider, we're going to require that library within the Truffle config file, so then we can start using hdwallet-provider. Basically, this file is just the configuration for Truffle. So Truffle knows what wallet you're going to use, what network you're going to deploy to, and then some extra configuration so that we can make sure that the deployment runs smoothly, we're paying the correct amount of gas, and also the correct gas price. So we've added a network to which we will deploy our contract, and that's going to be Ethereum. You can actually have multiple networks in here. You could have Ethereum, Polygon, Avalanche, whatever you like. But we're just going to have Ethereum, and then we're going to say exactly what node in Ethereum that we're going to be connecting to. So this is what the provider section is basically talking about. We're starting a new hdwallet-provider. We're putting in our secret wallet phrase, and then we're saying we're going to connect to this node. I'm using Infura here. I have like a free plan on Infura. I wouldn't recommend using this one because I might have shut down the account or not be using this anymore. So it might not be particularly reliable, but you can create a free Infura account. Just Google Infura, and it takes 2 seconds, and that will provide you with an Ethereum node to which you can connect and start sending requests and commands to the Ethereum network and start messing around with the Ethereum network. So I would definitely recommend using Infura for that. It's free, so no worries. The next thing in this list of stuff is the network ID of the network that we're going to be deploying to, and that's the Ethereum mainnet. So that's just one. It's the Ethereum mainnet. It has a network ID of 1. If you want to do something like Polygon, let's say, it would be 137. Binance Smart Chain has its own network ID. Every network has its own unique ID. The next thing that we're going to be looking at here, and this is an important thing which you're going to have to figure out what to set it for yourself, but I'll explain to you how you're going to do that. The gas price, the cost to get the Ethereum network to do computational work changes based on the congestion on the network. If everybody wants the Ethereum virtual machine, the Ethereum network, to do work at the same time, then there's kind of a bidding war going on, and the price for doing that work will increase. When congestion goes down, the price will obviously decrease. And there's an extension that you can add to your Chrome browser. I'll just open up Chrome here. It's called ETH Gas Station, and it pops up here. I'll obviously leave another link in the description so that you can add that. But basically, it just says the recommended gas price that you should set in your Truffle configuration to be assured that the Ethereum network will pick up your request and say, that gas price is high enough, it's worth doing, and the miners will compute that for you. So right now, the gas price for me is 98.8 Gwei. And I have this gas price here set to 60 Gwei. So if you wanted to change it to 98, you would just change that to 98 like that. And so depending on what the gas price is right now, you should act accordingly. Another thing you could do is just Google ETH Gas Station, and then that's a website that will just for free tell you what the Ethereum gas price is right now. But the gas price changes all the time. So if you can afford it, I would say add, maybe 20% on top of what the gas price is saying to you, just in case there's some kind of gas spike that's unexpected, if you want this to run really smoothly. So the next thing that we're going to talk about is the actual amount of gas. So we have the gas price. That was the last thing we spoke about, and that's the cost of doing one atomic piece of computational work on Ethereum. So every single piece of work costs 98 Gwei, but the amount of computational work that is going to be required for deploying our contract is about 3 million, like 3 million, atomic computational cycles, you can think of it as. So actually, some of the time you can get away with about 2 million, but the cool thing about Ethereum is if you give it too much gas, it won't use all the gas, and then you get refunded the bit it didn't use. So there's no worries just setting this gas amount a bit higher just to make sure that it all works out. And as long as your contract actually compiles properly and isn't doing anything really weird, it won't use all of the gas that you specified. So I just set it to 3 million. But if you want to have a play around with that, that doesn't really matter. And then the next thing that I put into this configuration is skipping the dry run, which basically means don't compile it and pretend to deploy it, make sure that it all works, and then go again. Just go straight in raw. Do it for the first time. I've done this contract a few times. I know that it all works, so we don't need to test it or anything like that. The next thing in this list is just stuff you don't really need to know about. It's what compiler version we're using. So we're using the Solidity compiler 0.8.12. But this next little bit is a little bit more important. There's something called the optimizer, which makes your smart contract sort of compressed and cost a lesser amount of money to be deployed to the network. And so we've enabled, if you type true into the optimizer and then you say how many runs it can do, the more runs, the more compressed it will become. There is obviously diminishing returns there, but if you just change the runs to 999, 0.09999, then that's basically the maximum amount of compression that will happen to it, and the cost will be decreased for deployment. And then we're also just saying that the Ethereum virtual machine version that we're using is Byzantium. And there are a few different versions, but this one seems to run fine. Maybe it would work on other versions. I haven't checked, but this is kind of the standard sort of recommended one that you should use. So that is the truffle config. Again, I will leave that in the description. You don't have to type all that out manually. You can just copy paste it, but just make sure you change this Infura thing, because this Infura might not be available when you're watching this video, and it's just like a free version that I have. So I would definitely recommend changing it to your own version. So now that we've done that, the next thing we're going to do is we're going to look at the actual smart contract that we're going to be deploying. And how all of that works. So basically, when we typed in this command, npm install OpenZeppelin contracts, we pulled the library of OpenZeppelin smart contracts, the standard set of contracts that OpenZeppelin has as, a guide, as a help for us to deploy safe contracts that have been used before. We pulled that into our node modules folder. So if you open your node modules folder and then you go to @OpenZeppelin, which is somewhere around the top here, and you click into that, you'll see that we have all these other folders, and these are all different kinds of smart contracts that OpenZeppelin offer for us to use. We're not going to use most of them. We're just going to use some of them in the token folder, and within the token folder is ERC20 because we're deploying an ERC20 token. And then there's a few options here. So something to understand about ERC20 is that it's sort of a framework or a boilerplate for further extensions on more specific applications of ERC20. You can't deploy ERC20.sol, the standard ERC20, because it doesn't have all of the functionality there for a fully fledged token. You have to extend it. And I'll just show you a little bit of code that explains that in a nice amount of detail. So basically, if you go into ERC20.sol, you'll see a comment here that basically explains that. I'll just read it to you. So the supply mechanism has to be added in a derived contract. This implementation is agnostic to the way that tokens are created. So if we just deployed this contract, we wouldn't actually be able to create any tokens out of it. We have to deploy an extension on this contract which specifies how tokens should be created, under what conditions they can be created, and things like that. So if you come back into this folder structure here, and then you open the presets folder, you'll see that we have two different kinds of contracts that we're going to choose from. We're going to be choosing the ERC20 preset fixed supply contract. And we're going to be picking that for two reasons. The first reason is that when we deploy this contract, the preset fixed supply contract, we can specify in that moment how many tokens should be deployed with the contract, how many tokens we should have, in that moment, and also who should receive those tokens. But the second reason is, as the contract owner, as the person who deployed that contract, we can also decide, hey, 5 minutes later or an hour later, I want to actually increase the total supply of tokens. I want to mint some more tokens and give them to this person over here, or give them to myself. And we have full minting permissions over that contract. So we have two advantages there. We can specify how many tokens there are in the beginning, and then we can create more tokens whenever we like. So that's quite a flexible ERC20 token. There are other tokens you can choose from. There's also this other one, ERC20 preset minter pauser. I would encourage you to have a look through all the different ones. There's a whole bunch in the extensions folder as well. But if you do go in here, just make sure you take a look at something called the constructor. If I just look for the word constructor. In fact, it would be better if I show you in the preset minter pauser. The constructor has a number of arguments. So the name of the token, the symbol of the token, things like that. Each of these constructors have different arguments that they take whenever you build the token. So when you're experimenting with these, just be aware that you might have to add more information in the next part of this tutorial, which is the deployment part. And that will all make sense once I've explained to you how the actual deployment works. But just be aware that each one of these tokens is configured slightly differently. You might need to give it different kinds of information for it to deploy successfully. So the next thing that we're going to look at, and we're going to do preset fixed supply. That's just probably the most straightforward one that we could do. The next thing that we need to look at is something called the migrations folder, which is just up here. The migrations folder is a folder with JavaScript files inside, and those JavaScript files are responsible for the actual deployment of the smart contract on the blockchain. That JavaScript file, those JavaScript files, they're the ones that are sending messages to the blockchain to say, deploy this, now deploy that, now do this. They're in charge of the actual migration, is what it's called. And so these files, we only have one file for us right now, but just a little bit of information. If we had many files in here that were doing many complicated tasks that were all intertwined, those files would by default be conducted in alphabetical order. That's why it's called number 1 initial migrations. But then we could have a file that starts with the number 2, and then Truffle would just know to execute number 1 first and then number 2 second. And so you might want to do that if you were deploying many complicated smart contracts that had to be done in order so they could be all tied together in some kind of fancy way. But for now, we're just going to have this one file, and then I'll just explain to you the content of that file so that you can understand what we're doing. So another thing I should do just before I explain that is just to say that we've created a contract called MyToken.sol in our contracts folder, and that is going to be our version of ERC20 preset fixed supply that we're going to deploy to the blockchain. So now that we've chosen ERC20 preset fixed supply from the Open Zeppelin library, we're going to say, okay, we're now going to create a new Solidity file, a new smart contract, and we're going to inherit all of that functionality, and then we're going to deploy that. So in our contracts folder, you can right click and click new file and then call that file mytoken.sol, and within this file we're going to put all of the code that is responsible for launching our ERC20 preset fixed supply token. So I'll just go through every single line here in a little bit of detail so that you can understand exactly what that means. The first line in this contract is just saying what compiler of Solidity that we want to use so that the Ethereum virtual machine can understand and break down this code into machine code and understand what's going on. The next thing, line 3, is an important line, which is basically saying we're importing from that Open Zeppelin library the ERC20 preset fixed supply token. So it's like saying take all the code from that file and just shove it in here because we're going to need it. The next thing is we're going to create a contract. We're going to call it MyToken, and we're saying that it is an ERC20 preset fixed supply. So we're inheriting all of that functionality from ERC20 preset fixed supply. And then within these curly braces, we're basically defining the specific functionality, the specific configuration that this contract needs to know to be able to deploy properly. And so remember when I spoke about how all these different contracts, where's my node modules? All these different contracts have different requirements for being deployed, different information that you need to put into them. That is basically this line here, the constructor. We're saying we're going to construct an ERC20 prefixed supply, and then we have this information, these arguments within this code, that this one is what the name of the token is, this one is what the ticker of the token is, how much supply it's going to be, and then who gets that supply. So if you look in the ERC20 prefixed supply.sol, we have a constructor here, and it expects a name, it expects a symbol, it expects an initial supply, and it expects to be told who the owner is. If you come back into this file again, this file I should say, the actual contract file, you'll see that we've specified all of that information inside of the constructor. So if we were going to make this other one, the ERC20 preset minter pauser, and we look at the constructor, it seems that the constructor only needs to know the name, and it only needs to know the symbol. It doesn't need to know as much information as the ERC20 preset fixed supply needs to know. So if you're going to deploy a different token, just make sure you familiarize yourself with what the constructor says it needs, and then you'll be able to deploy it successfully. So now that we've added all of this information, and I'll just explain as well what line 7 means. Line 7 means we're going to have an initial supply. We've made a variable called initial supply, and it's going to be 10,000, and it's going to have 18 decimal places. Basically, Solidity doesn't do floating point numbers like traditional programming languages. If you're going to have a number like the number 1, for example, it will be represented as 1 with 18 zeros on the end. So the number 10,000 is 10,000, but with another 18 zeros on the end, which is a very big number, but in Solidity, those 18 zeros are actually just the decimal places. So it's a little bit different with how it deals with decimal precision. So that's the initial supply. So now that we have all of that sorted out, it's time to go into the migrations file, the JavaScript file 1 initial migrations, and actually tell the migrations file the steps for our deployment. So the first step of our deployment is to actually pull the MyToken Solidity code into here, make a reference to it, and say we're going to deploy MyToken. And then the first thing we're going to do is we're just going to console log the sentence deploying MyToken, and then we're going to say actually do the deployment. So our deployer is going to deploy MyToken, and then once that's actually done, it will say deployed MyToken. token. And so now that that's all sorted out, basically the only thing that we need to do is actually tell it to run this deployment. So what we need to do, we need to type truffle migrate -- network Ethereum -- reset. And once we click enter on that, it's going to begin that deployment. Now I've already deployed an Ethereum smart contract today, and it would have cost me $300, but I actually canceled the execution halfway through, but just so I could show you exactly what information you need to know once it's deployed. So once you click go on that command, you'll get this message starting migrations. It will say what network it's doing, the network ID, the block gas limit, all of that stuff, which we specified in the truffle config. And then it's going to go into the migrations and start deploying the token. So this piece of information here is that line number 5, deploying my token. And then it's going to actually start deploying it. And once it starts deploying it, it's going to give you a transaction hash. This hash is the transaction receipt on the Ethereum network. And if you copy that transaction hash and then go to Etherscan and type it in to the search bar and click enter, you will get all the information about your smart contract on Etherscan. And that basically signals to you that the token has successfully deployed. Now, I canceled the transaction halfway through because I didn't want to pay like $350 just to do a deployment when I didn't have to. I could still show you how it all worked. And when you deploy your contract, there's going to be a link here, probably a hash, like an address, just like this one. And if you put that into your MetaMask wallet by clicking MetaMask and then clicking assets, scrolling down to import tokens, and then adding that in here into the custom token section, you'll then have those tokens being tracked by your MetaMask wallet, and then you'll be able to send them to wherever you want them to go. But I canceled this transaction halfway through just because it was going to be really expensive because the gas price is so high. But that's basically how you deploy an ERC20 token. If you need any help, as always, make sure you hit me up on my Buy Me a Coffee page. I'll be more than happy to help you get through this deployment. And if you have any questions, make sure you ask them in the comment section. I'm also very active in the comment section. So I hope this was helpful to you. I hope you were able to deploy your ERC20 token, and I hope it wasn't too expensive with the gas price being so high. Thank you for watching, and I will see you in the next one.